Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today the question every LLM team eventually asks, should we just run our own model? And why the honest answer is almost always no.
That's a blunt opening from someone who clearly knows the topic. Defend it.
Because self-hosting trades a predictable API bill for three real burdens. An OPS surface you now own, GPU capital expense, and a team that actually knows CUDA. The conditions where that pays off are far narrower than the open source enthusiasm makes them sound. But there's a clean list of exactly when it flips.
Give me the list. When does running your own model genuinely make sense?
4 cases. 1. Data legally can't leave your network. Healthcare, defense, some regulated finance, where even a zero data retention promise from a vendor isn't enough for the compliance regime. 2. Steady high volume. Think 10 million plus tokens a day, every day on the same model. 3. You need a fine-tuned model whose weights you control and can ship as a binary. 4. You're latency bound at the edge, like on-device or factory floor, where a round trip to a hosted API is just too slow.
And if none of those 4 are true?
Then an API wins on cost, on velocity, and on capability. Full stop. And here's a sharp point people skip. The best open weights models still trail the frontier, hosted ones, by roughly 6 to 18 months on hard tasks. So most of the time the move is just pay the bill.
Okay, say I clear that bar. The first thing I hit is, will this even fit on my GPU dot? How do I do that math?
There's a back-of-envelope formula. Memory needed is roughly the number of parameters times the bytes per parameter, plus the KV cache, plus some overhead. The bytes per param is the lever. It depends on quantization, which is just how many bits you spend storing each weight. Full 16-bit precision is 2 bytes each. Squeeze down to 4-bit and it's half a byte.
Make that concrete with a real model, a 70 billion parameter model. How much memory are we talking?
At 16-bit, 70 billion times 2 bytes is 140 gigabytes, just for the weights. That doesn't fit on a single card. You need to a 180 gig GPUs, splitting the model across both. Now quantize that same model down to 4-bit. 70 times half a byte is 35 gigabytes. Suddenly it fits comfortably on a 100 or even a smaller 48 gig card.
And that 4-bit squeeze? What's the catch? You don't get that for free.
Surprisingly mild. Typically, a 1 to 3% quality drop on benchmarks, often invisible in your actual workload. For a roughly 4 times cost drop, that's a trade you usually take. But here's the real trap, and it's not quality. It's the GPU sitting idle. An idle H100 still costs around $2.50 an hour. If your workload is 1,000 requests a day, you'll spend more on idle GPU than the equivalent API calls would have cost, by a wide margin. What matters is your average utilization, not your peak.
Right. So the rented hardware is a fixed cost ticking, whether or not anyone's using it, while the API only charges when you actually call it.
That's the entire economic crux in one sentence. Which is why, if you do self-host, you cannot just run a basic script. You need to keep that GPU saturated. That's where VLLM comes in. It's the default open source inference server, not a model, a server. And it exposes an OpenAI compatible API while handling batching and memory for you.
What makes VLLM 5 to 20 times faster than the naive approach? That's a huge gap.
2 ideas. First, paged attention. Remember that KV cache in the formula. The per token attention state the model builds as it works? It's the single biggest memory hog during inference, and naively it wastes 60 to 80% of what it grabs. VLLM treats it like a computer's virtual memory, split into fixed size pages, allocated on demand, shared across requests, waste drops to under 4%. Second, continuous batching. Instead of waiting for a batch to fill or finish, it swaps requests in and out at every generation step.
Wait. So the instant one request finishes early, a new one jumps into the in-flight batch to take its seat?
Exactly. A short response that finishes gets evicted, and a fresh request joins immediately. So the GPU goes from maybe 30% utilization to over 90. One honest caveat though, this raises throughput, requests served per second. It doesn't necessarily speed up any single request. Each one's sharing the GPU with more neighbors now.
Let's talk quantization formats because the names are an alphabet soup. GPTQ, AWQ, GGUF, bits and bytes. How do I pick?
Match the format to where you're running. GPU production, reach for AWQ, activation-aware quantization. It protects the channels the model leans on most and gives the best quality speed trade-off, well supported by VLLM. Running on a Mac, a laptop, or CPU only, that's GGUF, the llama.cpp format. Slower per token, but vastly cheaper. And bits and bytes is for experiments and fine-tuning. Convenient, but too slow for production serving.
Now the question everyone actually came for, where's the break-even? When does owning the GPU beat the bill?
Even against a cheap hosted OpenWeights API, around 90 cents per million tokens. Self-hosting only wins at very high steady utilization. At full saturation, a rented A100 might get you down to roughly $1.40 per million, but run it at 20% utilization and your cost is 5 times that. $7 a million to serve a model. You could rent for 90 cents. So the rule of thumb, API wins under 5 to 10 million tokens a day or with bursty traffic. Hosted open weights like Together or Fireworks wins if you want open source without the OPS. And true self-hosting only wins above roughly 50 million tokens a day, steady, with an OPS team and compliance or custom fine-tunes pushing you there.
And I'd bet the GPU rental is the cost people see and there's a pile they don't.
That's the total cost of ownership trap. The hidden bill is on-call rotations for node failures, queuing under bursts, model upgrades every 6 months as open source races ahead, autoscaling that actually works for stateful inference, security patches on the whole stack. Small teams underestimate all of it by 3 to 5 times.
So the one sentence to leave with?
Start on a frontier API. Move easy queries to hosted open weights and self-host only when compliance, scale, fine-tunes, or the edge clearly forces your hand. And even then, keep the hosted path warm as your 2M fallback.
Measure before you optimize and the boring path usually wins. That's the Datarekha audio guide. See you in the next one.